In this video, we will look at different versions of a program that allows the user to enter values and output the average without first entering the quantity of numbers the user will be entering. Since we do not know the quantity of values ahead of time, we cannot use a for loop with a range sequence. We will use a while loop since the number of times the loop body will be executed is not known before the loop starts. Here is a sample that shows what we want the program to do. We'll start with a version that asks the user to enter a number and then asks if they have more numbers. Once they say no, it outputs the average. Unlike the original for loop version, where we ask the user to enter the quantity of entered values, here we do not, so we will also need to calculate the number of values. Inside the for loop, the user is entering one number, so we can use the accumulator pattern to calculate both the number of values and their total. Instead of looking at the final version of the code, we'll look at the steps you might follow to develop it. We know we need a while loop, and the loop body must execute the statements to input a value and build up the total. We'll leave determining the condition until later. As we mentioned, we also need to calculate the quantity of numbers entered. We can use the accumulator pattern for that also. And we need to ask the user if they have more numbers each time, so that needs to be in the loop. Now we can see we need to use the value of more in the while loop condition, as that tells us whether the user has more numbers to enter, and we need to continue executing the loop body statements. We'll get the first character and convert it to lowercase, and compare that to the letter y, so as long as the user enters any string that starts with a lowercase y, we will continue entering numbers. Hopefully you see that this will not work yet, as the first time through after initializing total and n, the variable more does not have a value, so it will crash when checking the while loop condition. We can fix this by copying the more line so it is before the loop also. Note that it is important to use the same variable more in both places, as the condition is checking the value of that variable. Inside the loop, we need to change the value of more so at some point later the loop will stop when the user enters a string that does not begin with y. But now the user must indicate if they have more numbers before they enter the first number. Presumably the user has at least one number they want to add if they're running the program. We can enter a value before starting the loop. We set total to the first value because that is the total after entering one value, and since the user has now entered one number, we initialize n to 1 instead of 0. This concept of essentially doing a portion of the loop body before the loop so we have a value to check in the condition statement is commonly known as priming the loop. Finally, we add the print statement to output the average when the loop ends. Note that because we add 1 to n each time the loop executes, when the loop ends, n will indicate how many values the user entered. We've repeated the two input lines so we can try to improve that. Since we know the user will be entering at least one number, instead of initializing more to a value the user enters, we can set it to y so the loop will execute at least once. That also allows us to initialize total and n to 0, as is more common for the accumulator pattern. The resulting code isn't any shorter. Which one you prefer is a matter of personal preference. We'll run this and enter a few numbers and see that it works. Although this version works without specifying how many numbers we will be entering, it is annoying when we need to enter y after each number. We'll make a new version using a concept known as a sentinel value. In a loop, a sentinel value is a special value that indicates the loop should end. If we're trying to average values that must be non-negative, such as scores on an exam, we can use a negative value as the sentinel value. The idea is the sentinel value should not be included in the calculations, but should end the loop. We'll start this version by initializing our total and n to 0, and writing our loop as this. Now we see we have the same issue as before, that x will not have a value the first time the condition is checked, so the program would crash when checking the while loop condition. We can't set x to 0 before the loop, because then we would be adding 1 to the value of n before we add any values to total. We could solve this by setting n to -1, but I think that is more confusing. In this case, I prefer the solution of priming the loop by copying the input statement. Note that we must use the same variable name for both input statements as we did here with x. The reason for this is the condition checks the value of x, and total accumulates x, so x needs to change each time to the loop. It must also hold the first value the user entered before the loop. Let's debug this one so you can watch both total and n change as we enter values. As we enter a few values, we can see that after we update total inside the loop, it holds the total for all the values the user entered so far, and after we update n, it indicates the quantity of the numbers entered. When we enter -1, the while condition is checked and the loop body does not execute, so the negative value is not included in the total, and n does not include the -1 as one of the entered values. When the loop ends, the values of total and n are exactly the ones we need to compute the average. We'll look at one more version in this video. Instead of entering a negative value as the sentinel value, we'll allow the user to simply press return to indicate they are done entering values. The result of pressing return is an empty string, which can't be converted to a number. Instead of converting it to a number as soon as the value is entered, we'll store the value as a string. We can check the value of the string as our while condition and only execute the loop if it is not an empty string. As before, we accumulate the total and quantity of values entered, and when the loop ends, we can output the average. We'll run it and see that we can enter a few values and then press return as the sentinel value, and it outputs the average. As you can hopefully see from these examples, when we are developing programs, we do not always write them line by line. Sometimes we purposely skip part of it knowing we need to go back and fill in the code, and sometimes after writing part of it, we realize we need to add some code earlier. It's always tempting to sit down at the computer and write the code, but if you do not have a good idea of how to solve the problem, or your initial attempt doesn't work, I recommend you use a piece of paper and write out an example of what you are trying to do. For example, if you were asked to write the sentinel version using the negative value, start by writing down a number and then write down the total of that number. Also write down that you have one number so far. Next, write down the next number, update your total, and update the quantity of the numbers. Write down one more number and update the total and quantity. Write down -1 and now compute the average. If you had forgotten to use the accumulator pattern to update the quantity, when you had tried to compute the average, you would realize you don't have a variable that holds the value 3. So you could go back and try again, adding a value to keep track of the quantity and updating it each time a number was entered. Once you've got your steps by hand working, you can then see what you did at each step and what variables you need. Now you're ready to convert it to Python code. So as we begin to work on more complex problems with loops and combinations of loops and if statements, I recommend you try out some sample data by hand to see what you need to do, and then write out the steps without the computer. This will allow you to focus on the problem without also worrying about the correct Python syntax. Once you know your steps are correct, you can then type it in. It may seem like this will take you longer, but unless you have the exact steps figured out in your brain before you start typing the Python code, you will lose time by repeatedly trying different code, and each time not only do you need to get the steps you will want to try worked out, but you also need to convert them to Python. As you gain more experience, you will be able to determine the steps for more complex programs without writing them down, and you will also be better at writing correct Python syntax. But even talented programmers often experiment on paper and spend time designing larger programs before typing in any code.